Wagwan, everybody. Welcome to the Disafimi History Podcast, where we'll be speaking about history and as well family history and how history relates in terms of Caribbean people for the present as well as in the past, and how in the past, what that does and brings forth for what we are going through at present and what we can learn from our history, from our family, and take that moving forward. So I do hope you enjoy the podcast. And if you like it, please ensure to subscribe, like, and review. Thank you.
Welcome to an intriguing episode of our podcast, where we venture into the world of genetic exploration with Peter J. Roberts. Today, we're diving deep into the Bahamas DNA Project, a groundbreaking initiative shedding light on the genetic mosaic of the Bahamian people. So let's have a listen.
Thank you so much, Peter, for coming on to the podcast to speak about the Bahamas DNA Project. And before we start, I'll just have you do a brief introduction of yourself.
Okay. Thank you for having me. From the Bahamas, I'm a Bahamian living in Atlanta, Georgia. I've been doing genealogy since about 1975, and I've been doing genetic genealogy since about 2003. I've had a keen interest. My mother's family was from Georgia and Virginia in the U.S., and my Bahamian family is through my father. All of his known ancestry is from the Bahamas. I knew very little about my Bahamian ancestry, and that's part of the reason why I got interested in trying to use DNA to learn more information.
No, thank you so much for that. And I guess we'll start off with what was your why to further delve? You kind of mentioned that you didn't know much of your Bahamian side, but, if you can just give us a little bit more as to why you delved into creating this whole Bahamas DNA project.
I was first interested in my Roberts line, my direct male line, and my great aunt had said that all the Robertses in the Bahamas were one family, except ours. We were not related to the other Bahamian Robertses, and I thought that was ridiculous. I thought we were probably one family, and DNA testing became available, Y-Chromosome testing, which looks at the direct male line, and I was able to discover that there are actually two Roberts families in the Bahamas. We've tested about 22 different Roberts lines that don't connect on paper, and they cluster into two different groups. They're unrelated Roberts families in the Bahamas, those two groups, but they all share a common. There's two Robertses that are the progenitor for these two Roberts lines, all these different Roberts lines in the Bahamas.
Wow, isn't that just so interesting to know that one name and you think it would be all under one family, but it's actually two different, which is fascinating. And so for how long have you been researching your family history, and how did the DNA part complement the paper research?
I started the DNA part in 2003 by just looking at Roberts, and then there was a fellow that had done research on the Shetland Islands, and he started a DNA project for that. And that encouraged me to do a Bahamas DNA project. And it's probably the second DNA geographic project in the world. And there was a lady in charge of the early genetic genealogy forum. She had encouraged me to do mitochondrial DNA testing, which has proved quite valuable also. So it's been quite a journey. Unfortunately, it costs money, and not everyone can afford to take a DNA test. So quite often, a lot of the results that I have are based on the results of people who can afford to test. We do have some sponsorship that's available, and so we've gotten about 250 to close to 300 people now that are part of the Bahamas DNA Project.
No, that's great. And then I guess what have been some of the major points that you have been gleaning from this particular Bahamas DNA project?
We've discovered that there are some families that are one family. In terms of there's a Kemp family and a Pritchard family, and it's probably one family. More DNA testing is needed to try to flesh that out. But we've been able to discover the origins of some family lines. There is a Lowe family in the Bahamas that was always believed to be coming out of England, earlier on, if it is coming out of England, earlier on it's coming out of Portugal, however it is. And that is one of the few families in the Bahamas that believes that they trace back to a pirate. And so they've got an unbroken genealogy, supposedly, that goes back to a pirate, and looks like it's Portuguese and probably of Ashkenazi origin. So it's really quite interesting. And we're also looking for a Low. This is the Low family, and we're looking for a Low from Barbados to take a Y-chromosome test, and that would be a free test in order to confirm this family story of the Low pirate the family line originally came from Barbados. So we need a Low from Barbados, Lowe.
Wow, that's just, as I said, this is what DNA does. It just brings out a whole bunch of different things and kind of helps to connect the dots. But I guess before we go any further, because you mentioned a couple of terms that are mentioned here that we may probably need some defining of. So would you be able to define in terms of what is Y-chromosome testing?
It's a type of DNA that is passed virtually unchanged from father to son. So virtually unchanged is that the Y DNA of a father and a son is going to be, in most cases, going to be exact, identical. The DNA test looks at little variations that can happen on the Y chromosome, and you're able to reconstruct family history based on those variations. The inexpensive test looks at 37 markers, and if two people match closely on 37 markers, say 35 out of 37, they match 35 out of 37 markers, then you can say that they share direct male line ancestry in a genealogical time frame. And that's the time frame in which surnames have been adopted and get inherited from father to son.
Okay. No, go ahead.
And we also look at mitochondrial DNA, and that is the DNA that is passed virtually unchanged from a mother to her children. Males have mitochondrial DNA that they just don't give it to any of their children. So it's a direct female line, and males can use their mitochondrial DNA results to trace their direct female line. And that is the most interesting line because a lot of women change their names each generation typically, and it's very difficult. Quite often, people know less about their direct female lines. And so you're actually able to reconstruct family relationships that may not be in the paper record. And you can see that if you were to go mother, 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 mother on one line and mother, 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 mother on another line, they would eventually connect. And hopefully you're looking at a connection on an island. And then you can see which family groups are related. One interesting thing is that we've tested about over 200 different female lines that come out of the Bahamas. Half of those lines descend from 7 women.
Wow.
So 7 women who lived in the late 1600s or the early 1700s. Those 7 women are the matriarch for half of the white Bahamian population. That's not the case. There's a lot more diversity amongst them, Bahamians of African descent on the direct female line.
No, I mean, this is just fascinating to know that you can trace on the Y chromosome, which is the male line only, and the mitochondrial DNA line, which is going to be mother, but mother provides that to both of her children, both male and female, right? So
yes. Now, a lot of people that hear about genetic genealogy and DNA testing for genealogy, what's very common is the autosomal test, like an Ancestry DNA test. That's very common. Also like 23andMe. That is most useful in the last 5 generations or so. So if you're looking at, what are my origins? Where am I coming from? On which lines are those origins? Then you want to do mitochondrial testing of yourself or of specific cousins. But when you take an autosomal test, it's very difficult to actually determine, well, here I have some African ancestry or some European ancestry. Which of those ancestries was that? Quite often it's quite difficult to nail down which ancestors are associated with that type of DNA with the origin from different continents.
Yeah, no. I know that I know for myself personally and my brother, we are doing in terms of autosomal testing, and that's mostly for health reasons to determine what are, I guess, the predispositions of some of these health issues and what is coming in the family. And I'm glad that you mentioned it only go back a certain amount in terms of 5 generations.
It can go back further, but that's where you start seeing ancestry dropping off.
Yes.
You may not have any autosomal DNA from a 7th great grandparent.
Exactly. And we won't go into that because that's another show
For sure.
to talk about how, markers or certain aspects of the DNA gets transferred and muted to the next generation. So you're right. Nothing necessarily will be seen from, let's say, an 8th or 7th generation into present day. So, and again, this is going again to the back is to how far back does the testing in terms of with Y and mitochondrial DNA can go back into history? As an example, ancient ancestry.
Yeah, for sure. Y DNA goes back about 234,000 years. That is when the common ancestor on the direct male line for all humanity is believed to have lived. And then for mitochondrial DNA, it's about 155,000 years ago. So if you were looked at your mother's mother's mother, we all unite to a matriarch that lived about 155,000 years ago. Both of them lived in Africa. And there were men that lived at the same time. They call him this patriarch, they call him Y-Chromosome Adam. For fun in a sense, but there were men that lived before him. There were men that lived other men that lived at the same time, but he's the only one that had at least 2 sons who had sons who had sons who had sons to the present day. And similarly for the mitochondrial DNA, she is the one woman that had at least 2 daughters who had daughters who had daughters to the present day.
Wow. Again, just amazing. Would you say that there would be an increased variation of European DNA in the Bahamas based on your project?
Not particularly. One of the things that is kind of interesting is that we've got Bahamians of mostly European descent who have a African Y chromosome. And we have Bahamians of mostly European descent that have an African mitochondrial DNA. And then there have been some people that there's one particular fellow, he was mostly of African descent from the U.S. He was a Pindar. He didn't realize that he was connected to the Pindars of the Bahamas. And that through Y-DNA testing, he connected with the Bahamian Pindars that come out of England. And so he is of mostly African descent, but he had always assumed that his direct male line was also African, but that was not the case. If you look at, they've done DNA studies in the London area, and they've done DNA studies in the U.S. looking at people of mostly like West Indian descent in England, and there is a high percentage of European Y chromosome. That is not. Of the Bahamians that have tested so far, it's not very clear. There's a lot of the Bahamians males that take a Y chromosome test is coming back African if they're of mostly African descent. But there's actually a lot more Bahamians of European descent that have DNA tested because they've got the leisure time and the interest to do the DNA testing.
No, again, just amazing as to what this whole world opens up of DNA. So would you say that the Bahamas DNA Project provides a snapshot of how African DNA has expanded not only in the Caribbean, but outside of the area? And additionally, where from the African continent that we're from?
The way I kind of visualize it is that you're looking at a keyhole in terms of the African diaspora. If you're focusing on, where are Bahamians coming from in Africa? You're looking at a keyhole, and so you're not getting the full picture. It's only a small portion of that African diaspora, and it's mostly actually coming from, as you know, the historical documents, West Africa. There is some Central Africa, but for the Bahamas DNA Project, a lot of the DNA is coming from the Cameroon, Ghana, little bit Nigeria. I've got so Ghana, Nigeria, the Cameroon, that's for the Y-chromosome. And then for the mitochondrial DNA, it's mostly Guinea-Bissau, Cameroon, Sierra Leone, and Gabon.
Wow, that's amazing. So that's primarily for the mitochondrial DNA is kind of slightly different in terms of where it's coming from.
Yeah.
The continent. Wow.
And that could just be chance, however that's happening in terms of, the descendants that are living today on the direct female line. It's just could be partly chance.
Mm-hmm. Now, I know you mentioned some of the ethnicities, but what has, from the Bahamas DNA Project, what has been some of the major ethnicities that have come through and shown through this DNA project?
Okay, so most of the results are of European descent in terms of like the typical English. We've got some Ashkenazi, English, Dutch, Scottish, Irish, North Viking, Welsh, Portuguese. There's one Berber line. That's quite interesting. It's of Spanish descent. That Berbers were in the North Africa.
Yeah.
Balkan, French, Germany. But there's a multitude of different ethnicities in Africa. But a lot of these, I'm probably going to butcher the pronunciation, but there's the Bassa, the Chadic, Iwando, Mandura, Bamileke, Fali, Bubi, Fang, Mandingo, Hassa, Bambara, Mandinko, Wolof, Limba, Mende, Lamba, Iwi, Fanti, Ga, Akan. That's some of the different ethnicities. Some of them are language groups, some of them are ethnic groups.
Mm-hmm. No, because I mean the Bahamas is about 100 different islands, so just to know that this has so much, a rich diversity of ethnicities is just amazing.
And most of those are coming out of New Providence Island, where Nassau is located. Yeah. But there's most of the people that have tested are coming from 3 islands of the 100 or so. Yeah. These are the 3 most populated islands. So you're looking at Abaco, Eleuthera, and New Providence. Most people are from. And I'm actually I've recently retired, and I'm hoping to focus on getting some DNA testing done on some of the southern islands, which are underrepresented in the project. Yeah.
I know for myself, I visited I think it was San Salvador. It's one of the more eastern islands, and not so much as populated, but wow, just amazing. Because I know they have a statue or a monument for when Columbus first arrived on the island in 1492. So, that's what I meant.
One thing that I was quite interested in finding out if any of the indigenous Lucayan Indians or any of their DNA is found in the current population. There are some hints of DNA that's coming from Native Americans, but it's not clear at all. It's probably not coming from the indigenous population that met Columbus.
Yeah.
And we've done the National Geographic's Genographic Project actually did some testing of archaeological burials in the Bahamas of the Lucayan Indians. Yeah. And so we know what some of that DNA looks like, and it's not being found in the current population. There are some groups that trace their origin in the Bahamas back to Cuba. There's a mitochondrial line that's going back to Cuba. At first, we thought that might be, it's Native American, but we thought it might be indigenous to the Bahamas, but it's actually seems to be indigenous to Cuba.
Wow. Yeah, because I know the Lucayan, the Taino Siboney, because they have traversed the entire Caribbean, that there's pockets of their ancestry. So what does it mean when someone, I guess, from the group would, match in the Bahamas DNA group, but they didn't know that they were related? And what would be some of the identifiers in terms of people matching?
Yeah, one of the things that jumps to mind is that I mentioned earlier about the Pindar, who they matched in the Bahamas, and then they basically learned a lot more about their ancestry. It's mostly that type of discovery is mostly coming through people that have been adopted and they've done an autosomal test, and they find out that they've got a lot of matches in the Bahamas. And there are a few adoptees where they've actually been able to discover their biological father, because they would match one particular Bahamian at a second cousin level, another Bahamian at a first cousin level, and by sort of, in a sense, triangulating, they're able to narrow down, who is the likely father. And then they actually tested a son of that father, and then there was a very close match indicating that it was a close relationship, and that they were a first cousin to that person who tested. And then they're able to figure out, well, this is probably the father. We are actually able to introduce also X chromosome matching also to determine who the actual father was.
And what would you, I guess, I'd use as an identifier for this match? Like, how would that be determined?
Okay, so with Y chromosome, let's say you test a Y chromosome, then you're going to be matching almost identical. So we're looking at the different markers. Like the common test is 37 markers. We're looking at a match of 34 out of 37 or 35 out of 37 exact people matching. Or with mitochondrial DNA, it's almost always in a completely exact match. So you're looking at different regions of the mitochondrial DNA. There's 3 major regions, and you're matching exactly. And so when you then you know that you've got the direct female line. When you've got a couple of differences on the mitochondrial DNA, the common ancestor might live 20,000 years ago. Or 10,000 years ago. So when you have just a small number of differences, chances are it's a very early common ancestor.
Wow. Amazing. And, through the Bahamas DNA Project, were you able to see individuals that were, direct descendants from the continent of Africa? I know you mentioned some of the other things, but does it really show in terms of direct, or I guess kind of seem like they're 100%, so to speak?
Okay. So in most cases, people will take a test, and then the lab that they tested with, they've got a database of different African types of mitochondrial DNA or different types of Y chromosomes. So you're matching with them. Okay, so most common is that you'll match at more than one ethnic group. That particular type of Y chromosome or that particular type of mitochondrial DNA is being found among different ethnic groups. What was interesting in the case of my sister-in-law's father's direct female line is that he matched a bunch of different ethnic groups, but they all centered around the Giba River in Guinea-Bissau. So there's a major river in Guinea-Bissau, and they're matching about 7 different ethnic groups that live on that particular river. So that mitochondrial DNA is probably coming from that river. And that doesn't exist in the paper record, but that's something that can show it's possible for DNA matching with ethnic groups in Africa to pinpoint an area of origin. Unfortunately, that's not it's more likely that you're going to just match a bunch of different ethnic groups, and they don't have one might be they're different parts of West Africa, and some might actually be in Central Africa.
Yeah. That is very specific to be down to this particular river in Guinea-Bissau to know that that's where they come from. That's again, just amazing.
Yeah.
And, your project, gives the connectedness that everyone is connected. How do you feel that, this really does illustrate that from the Bahamas DNA Project?
Okay. So we are all cousins. Some of us left Africa more recently than others. We all come out of Africa. One of the things that is to try to visualize that, to recreate that in your mind, if you imagine that the world's population is a deck of playing cards, 52 cards, if you take 7 cards out of the deck, those 7 cards represent the people that left Africa and populated the rest of the world. So in Asia, Europe, the Americas, there's very little genetic diversity, relatively little genetic diversity. In in Africa, there is immense genetic diversity. But we all come out of Africa. We started to leave Africa about 90,000 years ago.
Mm-hmm. Wow. Amazing. And, would you have, we can continue talking for this for hours, but we don't have hours. So just, I guess, your final thoughts in terms of how you would like to lead the audience in terms of with, let's say, looking at your DNA, what you can be able to expect, or, will it match with what you've uncovered through your, paper trail type of thing? Like what kind of advice you can give to the listeners?
It's going to be easiest to take the common tests like an autosomal test offered by Ancestry DNA or 23andMe. I would encourage people that are interested in learning more to take a Y-Chromosome test and a mitochondrial DNA test. And those are being offered by Family Tree DNA, which was one of the earliest labs to do DNA testing for the public. I hope more people from the West Indies will do a DNA test. I hope there are some countries that don't have a project, and so I hope that somebody will step up and start a project to encourage people from that island to do some DNA testing. There's a lot of free information out there. I helped create a database for mitochondrial DNA and Y-chromosome DNA called Mito-Y DNA. And that's a free site where you can upload your mitochondrial DNA and your Y-DNA, and you can compare with different labs. So it doesn't matter which lab you tested with, you can compare those Y chromosomes or the mitochondrial DNA. And there's also a free database for an autosomal testing called GEDmatch. And then if there's a free genealogy site, it's a one world tree for the world called WikiTree. And I'm wearing a WikiTree shirt right now. It's a free site. It automatically associates your DNA with your ancestry. And so if you have your ancestry in WikiTree, then if you say what DNA information what DNA tests you've taken, it automatically associates that DNA with the ancestry. And you can compare people in the genealogy database, you can compare their DNA because it interfaces with the testing lab, the databases at GEDmatch and also at Mito-Y DNA. So that's a lot of free information, and what I love doing is helping people. And so if you reach out to the Bahamas DNA Project, I love answering questions.
No, perfect. I will definitely link those in the show notes so people can see those links and your contact information, because as with most people that do their family history or genealogy, definitely the assistance, the help, the community of it is to be able to help anybody else as to where they are at whatever step or block that they may be at. So, Peter, I just want to thank you so much for coming on and speaking about this project. I think it's just quite fascinating. And what you're, further revealing on a kind of like a global scale is that we all are connected. As you said, we're all cousins. So, and of course, that variation coming from the continent of Africa, further expanding throughout the world. So thank you so much.
Thank you so much for having me. I deeply appreciate it.
Not a problem.
Hoped you enjoyed this episode, and if you did, please make sure to like, follow, subscribe, and write a review for the episode wherever you listen to your podcast. Thank you.